Well, I'd really like to know how the Great Pyramid was built. And we now have, with new tech, with scanning technology, it's now become apparent that there are many major voids within the Great Pyramid.
Archaeologists call the Great Pyramid a royal tomb built by brute force and copper tools, but an explosive online discovery shattered that certainty. The exact latitude of its peak matches the speed of light, down to the last decimal. Is this just cosmic coincidence, or proof that ancient builders hid an impossible message in plain sight? One answer could rewrite history, but before you can believe it, you have to confront a flaw so big it nearly kills the theory on arrival. In the shadow of the Giza Plateau, the story of the Great Pyramid begins with a vision from a single man, Pharaoh Khufu, ruler of Egypt's Old Kingdom around 2580 BCE. To the archaeologist, this monument is not a riddle, but a record. The pyramid stands as the centerpiece of Khufu's mortuary complex, designed to secure his journey into the afterlife. Its construction required the labor of thousands, not slaves, but a rotating workforce of skilled stonemasons, surveyors, and seasonal laborers drawn from across the Nile Valley. Archaeologists have uncovered worker villages, bakeries, and medical stations, all pointing to a society mobilized for a royal project on a scale never seen before. Copper chisels and dolerite-pounding stones shaped each of the 2.3 million limestone and granite blocks. Quarry marks and unfinished stones left behind at Tura and Aswan show the process: cut, lever, drag, and haul. Ramps, built from mud brick and limestone chips, rose alongside the growing pyramid, allowing teams to move blocks weighing up to 80 tons. The tools were simple, but the organization behind them was anything but. Overseers used plumb bobs, sighting rods, and knotted ropes to keep every course level and every angle true. The royal cubit, a measuring rod about 52.3 centimeters long, set the standard for every dimension. Surviving rods from tombs and workshops match the pyramid's measurements within millimeters, proof of relentless recalibration and discipline. The pyramid's base stretches 230 meters on each side, aligned with the cardinal points. Surveyors used merkets, star sighting instruments, and simple water levels to achieve this. Modern surveys by Flinders Petrie in the 1880s and satellite data today confirm the north face deviates by less than 3 arc minutes from true north. No other ancient structure approaches this precision. The original height reached 146.6 meters, and the casing stones, polished to a mirror finish, would have caught the sun for miles around. At its heart, the king's chamber sits deep within the stone, surrounded by relieving chambers and passageways. Everything about the design serves a purpose: to protect the pharaoh's body and connect it to the heavens. For generations, this was the accepted story, an engineering triumph, yes, but rooted in the tools and mathematics of its time. Egyptologists point to the evidence left in stone, in burial goods, and in the records of the workers themselves. The pyramid was a tomb, and its mysteries were solved by the sweat of thousands and the guidance of the stars. Any suggestion of lost knowledge or cosmic secrets, they say, is a modern fantasy. The facts are right there, written in stone, measured in cubits, and built by hands that left their mark on every block. A single upload changed everything. One night, a creator sat at their computer, typed a string of numbers into Google Earth, and watched the digital globe spin. The camera zoomed in, slicing across continents, until it landed not in the middle of nowhere, but at the tip of the Great Pyramid of Giza. The coordinates on the screen, long and precise and almost mechanical, matched a number familiar to anyone who has studied physics: the speed of light. The video was short, almost offhand, but the effect was instant. Within hours, screenshots and clips started bouncing from Reddit threads to Twitter timelines. TikTokers stitched their own reactions, jaws dropping as the globe snapped into place at Giza's apex. YouTube channels with millions of subscribers picked up the story, amplifying the claim with glowing graphics and urgent music. Hashtags like hashtag Giza Anomaly and hashtag Speed of Light Pyramid racked up tens of millions of views. The headline was irresistible. Odds of this being a coincidence, millions to one. People who had never cared about ancient Egypt were suddenly arguing over decimal points and cosmic messages. Comment sections exploded with theories. Was this proof of lost knowledge? A glitch in the simulation? Or just a digital parlor trick? The more the video spread, the more the debate spiraled. Some viewers tried the experiment themselves, typing the numbers into their own maps and marveling as the pin locked onto the pyramid's summit. Others dug into the math, calculating the odds, posting diagrams and probability charts. Forums filled with speculation and counterclaims. Skeptics fired back, pointing out that latitude lines are infinite, and that with enough decimal places, you can make almost anything seem intentional. But For every debunk, another wave of believers joined the conversation, convinced that the pyramid's placement was no accident. The story leapt from niche corners of the internet to mainstream headlines. News outlets ran segments, some skeptical, some breathless. Scientists and Egyptologists were asked to weigh in. The pyramid, already famous for its scale and mystery, suddenly became the centerpiece of a global numbers game. Even those who dismissed the claim could not look away. The digital wildfire had done its work. The world was not just asking how the pyramid was built anymore. Now everyone wanted to know why this number, why this place, and what it could possibly mean. The mystery was out, and nobody could put it back in the box. In the wake of the viral debate, a single objection kept echoing. The meter. Critics latched onto it. They argued the entire mystery falls apart the moment you realize the ancient Egyptians never used meters. They said the meter is a modern invention, born in the chaos of revolutionary France, not on the banks of the Nile. But the real story of the meter is not a tale of arbitrary rulers or bureaucrats. It begins with two men, Jean-Baptiste Delambre and Pierre Méchain, and a quest that would send them across the length of France through revolution, war, and personal crisis, all in pursuit of a single universal standard. In 1792, as Paris reeled from the fall of the monarchy, the French Academy of Sciences set out to redefine the very measure of the world. Their goal was a unit so natural it would belong to all people, everywhere. They chose the shape of the Earth itself. The meter would be defined as 1/10,000,000th of the distance from the equator to the North Pole, measured along the meridian that passes through Paris. This was not guesswork. It required a survey of unprecedented scale, a geodetic mission from Dunkirk on the English Channel to Barcelona on the Mediterranean Sea. Delambre and Méchain were mathematicians, but their journey was anything but academic. They dragged their instruments, giant quadrants, precision rods and chains, across fields and mountains, through border checkpoints and battle lines. They climbed church spires, camped in hostile villages, and measured angles under skies thick with fog. Méchain, obsessed with precision, checked and rechecked every reading, haunted by the possibility of error. His notebooks record sleepless nights, broken equipment, and the crushing weight of responsibility. At one point, a chain snapped in the Pyrenees, nearly ending the expedition. In Barcelona, Méchain discovered a tiny mistake in his calculations, a fraction of a millimeter, that drove him to despair. He confessed the error in his diary, but the mission pressed on. After 7 years of hardship, the survey was complete. The arc from Dunkirk to Barcelona had been measured, point by painstaking point. From this data, the meter was born, not as an arbitrary stick, but as a slice of the planet itself. The first platinum meter bar cast in 1799 was slightly off by modern reckoning, but its purpose was clear: to anchor human measurement to the geometry of the planet. The original definition, 1/10,000,000th of the distance from equator to pole, made the meter a geodetic unit, a bridge between mathematics and the real world. This story matters because it reveals the meter as more than a French invention or a colonial artifact. It is a number pulled from the planet, not from thin air. The same geometry that defines the meter shapes every latitude, every meridian, every global coordinate. The tools were new, but the logic was as old as the Earth. The question is not whether the Egyptians used meters. The question is whether they understood the mathematics that would one day inspire Delambre and Méchain to measure the world. The royal cubit was the measuring stick of ancient Egypt. Carved in black granite and polished wood, it was the starting point for every pyramid, temple, and tomb, about 52.36 centimeters long. It was not an estimate, but standard, checked and rechecked against a master copy, with severe punishment for the smallest error. Surviving rods, found in tombs of architects like Ka and Maya, are not relics of guesswork. Each rod is divided into 7 palms, each palm into 4 fingers, for a total of 28 digits. Workshop inscriptions and stone grids at Giza show the cubit in use, marking out every course and every angle. This was more than a tool for builders. It was the backbone of construction, the language of precision. The base of the Great Pyramid measures 440 royal cubits per side, matching within a hand's width across 230 meters. The original height, 280 cubits, comes within centimeters of modern surveys. The discipline was relentless. Rods were recalibrated every month using the master rod kept in a temple or the pharaoh's court. Even the smallest deviation meant starting again. Workers used knotted ropes stretched taut, sighting rods, and water-filled levels to transfer measurements across the vast limestone platform. The cubit's length is not random. Take a circle with a diameter of 1 meter. Its circumference is pi, 3.1416 meters. Divide that by 6, and you land at 0.5236 meters. That equals the royal cubit to 4 decimal places. This is geometry built into the unit. The Egyptians may not have written about pi as a constant, but their rods and their monuments speak for them. The same ratio appears in the pyramid's dimensions, in temple layouts, and in the spacing of columns. Artifacts confirm the link. Cubit rods in museums from Cairo to Berlin, the incised palm and finger marks, the red ochre grids on casing stones, all point to a culture obsessed with measurement. In the Old Kingdom, overseers enforced accuracy with monthly checks. In the Middle Kingdom, folding rods like Kas carried the standard into the field. By the New Kingdom, the same subdivisions persisted unchanged across centuries. Experimental archaeologists have tested these methods, building replica walls and platforms. With only a cubit rod, rope, and water level, they achieve errors of less than a centimeter over tens of meters. The cubit is more than history. It is a bridge connecting the geometry of a circle to the stones of Giza. The builders worked in cubits, not meters, yet the numbers 0.5236, 3.1416, and 1 are the same. The link between the ancient rod and the circle is not a modern invention. It is carved into every measurement, every block, every course of stone. The royal cubit set the scale, and geometry set the rules. The next step is to see how those rules shaped the pyramid itself, and whether its design holds a deeper message about the shape of the world. The Great Pyramid is more than a feat of engineering. It is a monument that seems to mirror the planet itself. Its original height, 146.6 meters, multiplied by 43,200, gives a number astonishingly close to the polar radius of the Earth, about 6,332 kilometers. That ratio, 1 to 43,200, is not pulled from thin air. There are 43,200 seconds in 12 hours, the time it takes the Earth to spin halfway around. The base perimeter, when scaled up by the same factor, approaches the planet's equatorial circumference. These numbers are not just mathematical tricks. They are built into the stone, locked into the pyramid's proportions, and verified by satellite surveys and laser scans. Precision runs deeper than numbers on a page. The pyramid's sides are aligned to true north within 3 arc minutes, less than a tenth of a degree. For comparison, the prime meridian at Greenwich, set with 19th century telescopes, is less accurate. Flinders Petrie's theodolite readings from the 1880s, confirmed by modern GPS, show the north face deviates by less than 0.05 degrees. That is the difference between aiming at Polaris and missing by a fraction of the moon's width. No other ancient structure comes close. To achieve this, surveyors used Merkets to track circumpolar stars, stretching cords and checking levels night after night. The pyramid's footprint is level to within a few centimeters across 230 meters. Every course, every angle, every alignment, nothing left to chance. The monument stands as a geometric actor, echoing the scale and orientation of the Earth itself. Probability is a slippery thing, especially when numbers feel almost magical. The claim that the pyramid's latitude matches the speed of light to 9 decimal places sounds impossible until you look closer at how many chances nature gives us. The Great Pyramid does not sit on a single line of latitude. Its base stretches across nearly 1,000 meters, crossing more than 20,000 possible latitude lines if you slice the Earth as finely as our digital maps allow. Each decimal place in a coordinate zooms in further, turning a broad band into a pinpoint, but the pyramid's footprint is wide enough to catch plenty of numbers if you are searching for a match. Cherry picking is exactly what happens next. If you have enough data, you can always find something that fits. Statisticians call this the Texas sharpshooter fallacy. Draw the target after the shots land, and any cluster looks like a bullseye. The viral claim ignores all the lines that do not match the speed of light and focuses on the one that does. If you tried the same trick with longitude, or with speed measured in cubits per second, the pattern vanishes. Coincidence still nags at the mind. Even after accounting for all the latitude lines and all the ways to slice the data, the fact remains. The pyramid and the speed of light share a number, and that number sits at the intersection of ancient stone and modern science. Maybe it is just a quirk of math and measurement. Or maybe, like the pyramid itself, it is a riddle that refuses to be solved by logic alone. Today, the Great Pyramid's latitude and the speed of light remain bound by mathematical chance, or intention. As we decode ancient measures using global constants, our view of the past reshapes the questions we ask about our own origins. The numbers are still there, challenging certainty. Sometimes the message is not what was written, but that we are now able to read it. What do you think? Coincidence or design? Drop your thoughts below.